Alright, so this is going to be a video on how to use terminal or command line and Git. This is sort of a topic that they don't really cover in class, and you're expected to learn this on your own through Google and YouTube and other means. I sort of learned this during my first week of 280 back in fall of 2018, and also my roommate at the time who took 280 before me, and he also helped me out quite a bit. So basically what Git is it's a version control system for code. So if you're working with a partner, either with 183 or 280, it's easier to use Git than to use Facebook Messenger or email or Google Docs, where you're sending code across to your partner, copy and pasting it into your IDE. This stuff is a little hard for beginners. It's not very friendly when you're first starting out. So please don't be too hard on yourself if you've never seen this kind of stuff before, because I certainly didn't when I took 280. So to begin, this is where I start really, is I'm assuming you've already installed WSL for Windows and Homebrew for macOS. I believe the EECS280 staff actually have a setup guide on how to set those up, so I'll link that below if I find it. The very first thing you want to do is when you open up Terminal or WSL in Windows, you'll sort of be greeted by this sort of page. You won't have these, because these are sort of my own custom commands that I write that open up every time I open a terminal. So these won't show up, but like this definitely will. If you're on Mac, I believe you can just go directly from where you start out to where your project folder is. It's a lot easier to navigate. But on WSL, you have to backtrack a little bit to get to your main drive. So currently, if I do ls, which is this directory, nothing will be there. But if I do ls-a, you'll see that there are all these hidden files. These hidden files, you don't really need them if you're just doing your projects for now. They are pretty cool to look at later, to where like you can modify some of the files in here to get your own custom commands and make things easier for yourself. But for now, they aren't that important. So we're going to go ahead and navigate to where we want to save our project. So in WSL, you have to go back twice, and you'll be in your overall home drive. This is the same thing where I believe macOS starts you out at. Most of these files here aren't too important for you to mess with. The only important file here is M&T, so we want to go in there. Else again, and now you'll see your C and your hard drives. I have two hard drives, a C and a D drive, and most of my stuff in the C drive, so we want to go there. Now you'll see that all these files here are the same exact thing. If I open up the Windows File Explorer, you'll see that EECS281, 280, and 215 are all in here. When you're doing your projects, it's a lot easier if you make your overall folder for the class inside the C drive. That way that it's way easier to navigate through instead of saving them in desktop or wherever else. So like for example, EECS281, I have all my projects in here. For 280, I had all my projects in here. And the same thing for 370, where I had all my projects in here. It's just a lot easier than going to your desktop, which I'll show you in a second. It's just a couple more steps. It's a little bit more annoying. So if I want to go to desktop, go to users, go to my computer name, and now see desktop right here. So it's just a little bit more steps. And I want to go to this example folder I made earlier. And if you press Control L, you'll see that it'll clear your screen, clear all the clutter. Do ls again, you'll see that in this this folder, I have a bunch of files. We have the default files that Visual Studio creates you that are Visual Studio specific. For example, the SLN, the VCX projects, the filters, and the user files. And then we have the actual code and the test cases for the file. So for example, a text document and the CPP file. Now I have a command set for when you want to set up version control for GitHub with a partner, or if you don't have a partner. There's not any major difference between the two, only that when you set up version control for partners, it's definitely required to have a git ignore so that GitHub ignores the system-specific files that are specific to your computer and cause havoc on your partner who might be using Xcode or some other IDE that are not compatible with these files. So git ignore will ignore all these files and only push up these two files. So let's go ahead and start our repository. So we do git init. We initialize the repository. Okay, make clean. I don't have a makefile in this folder, but if you did get one with your starter files, it'll clean all the garbage files that you don't really need. For 183 and 280, you don't really need to worry about how the makefile works. Just knows that all it does is it cleans up all the random other garbage that you don't need. For 2D1, you'll need to understand how to use the makefile to submit to the autograder. So we're going to go ahead and copy this command. So we just got the git ignore file. If I do ls, you won't see it, but if I do ls-a, which shows all hidden files, you'll see that the git ignore file is here. And there's actually a git folder that git creates when you do git ignit. Let's go ahead and do git status. What this does is it shows us what files are being tracked by GitHub. So currently, because we added the git ignore, you'll see that GitHub ignores all of the Visual Studio specific files, which is good because you don't want them. And so let's go ahead and add all these files to a commit. You'll see that I did git add-a, and it said here to use git add with a dot. There isn't a lot of difference in either of these. You can use either one. Both of them just mean that you're adding all the files into a commit. If I do git status, you'll see that they turn green, so they'll be pushed up to the server the next time you push. So I'm going to do git commit and write a little message. You'll see that created these files. Okay, status, everything's still good. And now what you need to do is you need to go to GitLab. I'm going to use GitHub, but GitLab is pretty much the same thing, just university sponsored. So I'm going to create a new repository. I'm going to call it tutorial. One note right here is that make sure when you're doing stuff for your projects, you want to set your repository to private. If you don't, and you leave it as public, you may be subjected to an honor code violation. I don't really know what the chances are for that. I've never gotten honor coded, but they do tell you that when you do make a Git repository, make sure to set it on private. I'm going to leave it to public here because this is an example, it's not an actual project, and the projects are all empty anyway, so this will be public. So now you'll see this sort of page. You can use the SSH link or the HTTPS link. The only difference is that with the HTTPS link, you would need to type in your GitHub or GitLab username and password every time you want to push or pull. And that gets annoying after a while, so you can set up an SSH key for your computer and your account in GitHub to where you can just push and pull without a password, without having to type extra stuff every single time. I won't go through that here, that's a little bit more complicated setup, but there are definitely more YouTube videos that'll help you if you do want to set that up. So we're going to go back to my command set here. We're going to, I need to copy this link. And then we're going to do git remote add origin with that link. And this is going to link up that repository with this folder. Okay, everything looks good. And now we're going to type this in, git push -u origin master. You only need to do this command, this entire command here, the very first time you commit, which means your page should look like this. This will be the only time you should push up with the -u. What it's really doing is just saying that this commit is going to be the new head of your repository, and you just need to specify it because when you create the repository, there is no head. So this is just to specify that. There we go. Okay, so now, since everything's pushed up, everything is successful. If you refresh this page, you should see your files that you just committed. So that's pretty much it for if you're creating a repository. But now I'm going to go over when you want to push up a new change, when you want to pull up a new change from the server, assuming your partner made changes, and how you can run your code on Kane, which will give you more debug data because all the autograders run on a Linux system, and that's what Kane runs on. So if we want to push up a change, let's go ahead to our file here, edit this, and let's make a change. Okay, that's the change I want to make. Now, if I do git status, you'll see that I have a new modification to my code, and it'll show up in red. So for pushing, let's make it clean. It won't do anything here because I don't have a make file. We'll do git add all the changes we've made, git status, so you can see that it's turned green, and now you can commit. So git commit -n initial, not initial, let's say here we go, do that. So now here, if you know that your partner didn't do any changes and there's no changes to your code since last time you pushed, you can really just do git push. But it's always safer to fetch from the server first, take those changes, apply those over the changes you've made with git rebase, and if that is successful, you'll know that there will never be a merge conflict. So let's do git fetch. We're fetching code from the server. Okay, successful. Rebase, applying server changes over your code, and you'll see that there's no conflicts. So it's good. It's good to be pushed up. So now you can do git push. Awesome. If git rebase were to ever fail, it means that either you or your partner made a change to the same type of code, and GitHub doesn't know which change to take because it's not a smart system. What it'll do is reject your push, and it'll say, hey, you have a merge conflict. And the way you can resolve merge conflicts is a little bit more tricky, and I'll go over those later. So now I'm going to show you how to pull a change from the server. So let's go ahead and refresh this so we have our changes. See changes from me from the computer. Let's go ahead to this text document. And let's just pretend that I have a partner here, and he edits, or she, they edit from their computer and push something up to the server. So let's commit this change. Okay, so now if we want to pull it, we'll follow this protocol. So let's clear our screen. We'll do git status. You'll see that git status say, oh, your branch is clean, but you haven't fetched yet because your computer doesn't know there's been a change on the server. If you do git fetch, I'll find some data that's been pushed up, and do git status. You'll see that your branch on your local computer is behind the server version by 1 commit, because we made a change onto the server. So let's go ahead and make clean and do git fetch and git rebase. So you can also do git pull. It's not recommended. Doing the git fetch and git rebase is one layer of security, I guess, so you don't have anything that you accidentally lose. So let's do git rebase, and it looks like it's all successful. So if we go to the file on our computer and do edit with Notepad, you'll see the change from the server. Cool. That's taken care of. Let's go up to how you can compile your code on Kane. If you go to the spreadsheet here, which I'll link in the video description, go down to terminal commands, you'll see that there's this command set right here. SSH with your unique name to this login address. Basically what this does is it turns your terminal into an instance of a supercomputer that the EECS department has up on North Campus, and you can run your code on there, which is the same sort of operating system that your autograders run on. And you can run valgrind here, you can run perf to see if you have how you can limit things on time, or if you have any memory leaks. So let's go ahead and SSH into Kane. Sorry. Here we go. Type in my password. La-di-la-di-da. Any minute now. There we go. Cool. Now that we're in this folder, you'll see that on Kane, I have all these folders that I've created before. But we'll go ahead and make a directory using make dir. And let's name it EECS GitHub example. Let's change directory into that. And you'll see that there's nothing in this folder. So now what we want to do is we want to clone the repository onto the Kane system. So if we go back here and we go to repository, you'll see this button right here. It'll be the same thing on GitLab. You can either use the SSH or the HTTPS link. I'm going to use the SSH because I have SSH set up on my computer. So we're just going to do git clone la-di-da. There we go. If we do ls again, we'll see our folder here. And if we change directories to that folder, we'll see all our files here. The example project CPP and the new text document. If we do ls-a, we'll see the .git file and the git ignore file. So that's basically how you can clone onto the autograder. And then if you want to leave the autograder, the Kane system back to your original terminal, all you need to do is type exit. Boom, you're back. So now that we've covered the SSH into Kane and how you can run your code up there, last thing I'm going to go through is merge conflicts. Merge conflicts are when you and your partner edit the same piece of code and GitHub is confused as to which commit it should take. And it's just going to tell you that it's not going to accept either. So there is obviously the programmer way to go through it, where you can use git merge, you use all these separate git tools to see which one you can overlay, you want to backtrack, you want to merge the branches and all that stuff. That's a little bit too complicated for if you're just learning how to do it. The way my partner and I did it in 280 was that we'd copy the code that we wanted to push up to a separate file, then we deleted the original file, cloned the repository back onto our computer, made our edits, and then pushed that version back up with the correct version. And then you can delete the temporary files you made. That is by far the easiest way you can do it without learning all the extra heavy stuff that comes after this for Git. It's sort of clunky, but as long as you can keep track of which versions you want to keep, saving a backup, and then pushing up what you want, that is the best way as a beginner you can sort of resolve these merge conflicts. So yeah, I think that's all I had. I'll probably make some other videos that are a little bit shorter that shows you how to do each sort of push-pull SSHing and stuff, and I'll link those all in the description of this video. But yeah, good luck on your projects, and Godspeed.